Okay, let's finish exam 2 solution set. So last video we did a 9. Did we do 10? Oh, we did do 10. Yeah. So let's do 11. So 11, we're given a table, right? We have rows. In the row, we have speeding ticket, no speeding ticket, we have total. And we get columns. Columns, we have a red car, not red car, and total. So let's see. So given this, so we want to find the probability randomly choosing a person who did not get a speeding ticket, right? Those that did not get a speeding ticket in this column, given conditional probability, they have a red car. So we should look for red car first. So red car is here, right? Then the total people having red car is 150. So the probability is denominator is 150. Then how many people did not receive a speeding ticket, which we'll look at this one. So which is 135 divided by 150. And we can simplify this. So we divide by 5, we get a 27, right? 2 times 5, 10, well, remainder 35, that's 7. Then divided by 5, we get 30. Then we can divide by 3. 3 times 9 is 27. 3 times 10 is 30, so 9 over 10. So that's 11. 12. Compute the probability of randomly drawing 5 cards from a deck and getting exactly 2 diamonds. Right? Think about it, we draw 5 cards out. 5 cards out. So we only want to have any 2, so any 2 kings. We only consider 2 kings. So the rest of the 3 can be any cards. So what is the probability of that? Remember, deck of cards have 52 of them. So getting the first diamond means this, not a K. Right? Remember, the diamond card has this sign, and there's one shoot, and one shoot have 13 cards. So we have 13 diamonds. We have 13 diamonds in 52 cards. So the probability of getting the first diamond would be 13 over 52. The second one would be 12 over 51. Then the rest of 3 can be anything. So the third one can be any cards out of the 50 cards. Then any card out of the 49. Then any card out of the 48 cards. So we see this one is just 1. Right? This is 1, this is 1, this is 1 times anything. Right? So in the end, we just have to compute these two. 13 times 12. And well, 13, 52, this is a 1/4. Then 12 and 51, we can simplify it by 3. 3 times 4 is 12. This is 17. 3 times 17 is 51. So this 4 cancel with this 4. So in the end, we get a 1 out of 17. This is very similar to the review question where you consider getting 2 kings, right, out of 52 deck of cards. Also 1 out of 17. So that's 12. Let's see 13. 13. Let me erase this. So 13 is saying we're planning a catered dinner. So we have 3 choices. We want to have 1 choice of 3 main dish, right? So we have beef, we have bacon, we have chicken. So we can write on the side, Out of the main dishes, we want to choose one of them, either beef or vegan or chicken. Then a choice is of 3 types of side items. So for side items, we have roasted, grilled, we have R. Let's just see. If we first one we choose beef, we can choose R, we can choose G, or we can choose W, right? Out of these, same thing. Same, out of the same. So then another choice is of 3 drinks. We could choose a Pepsi. We could choose a sparkling water. We could choose iced tea. Of course, out of them, we have all 3 choices. So this question is asking us the least sample space of all complete dinner. You can just use these letters. So I need a bigger space. So we have to make a list. Like many of us forgot about to make a list. To choose 1 dish, 1 side, and 1 drink. Then it's asking how many probabilities, how many possibilities are there? So we need, so that's the cardinal number of the sample space. So first we need to list the sample space. So let me write here. So we have B, vegan, and chicken, right? So for first category. Second category could have R, G, W. Of course, for 3 of them, R, G, W. This is R. Space. R, G, W. Right, then for the drink. So drink for each one of them, we have a Pepsi, sparkling water, or iced tea. Same thing for G. Could be Pepsi, could be sparkling water, could be iced tea. Could be Pepsi, water, iced tea. Right, so all of them, right? So all of them, we should list 3, list 3, list 3, list 3. I just don't have enough space. List 3, so it could be Pepsi, sparkling water, iced tea. Right? Pepsi, sparkling water, iced tea. Pepsi, sparkling water, iced tea. So PSI, PSI. So one more here, PSI. If we count, there will be 27 of them, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Right, because each category, so here we have 3 choices. Second, we have 3 choices. Third, we have 3 choices. So 3 times 3 times 3, we have 27 of them. But the least the sample space, either we make this tree or we can put it in here, saying B, R, P. That would be one possibility. Then B, R, S. Then B, R, I. Then B, G, P. So on and so forth. All right. But if you make such tree, that's enough. Then you tell, okay, the cardinal number, the possibilities are 27 of them. So that's for 13. And many forgot to list all those sample spaces, but I still give you full credits for that because you answered the 27. You answer the cardinal numbers are right. All right, so the last question is 14. 14 is asking, in the presentation day, your instructor wants to choose the order of the presentation. So 18 students in total in the class. He wants to choose 5 presentations first. So the first 5 will be Jerry, these 5 people. So for 18 of them, so this 5 is already chosen. So 13, so we just have to permute the rest of 13. So you see, express your answer. So what is the probability? What's the probability that the first 5 has to be those 5 people? So there are 2 different ways of thinking about this. The first way is we talked about in the interview, in the review, exam review class. So, okay, choose the first person will be 1 out of 18. Second person, 1 out of 17. Then 1 out of 16. Then 1 out of 15. Then 1 out of 14, right? So 1, 2, 3, 4, 5. So this, then we multiply. So the denominator will get a big number in the denominator. So we just put into our calculator to calculate 18 times 17 times 16 times 15 times 14 to get a 1 million in the denominator though, because the numerator is 1 times 1 times 1 times 1 5 times, which is still 1. So it's 1,028,160. So the 1 out of this. So this is one way to think about it. Another way to think about it is, okay, 5 people have been decided. So we just have to permute the rest of 13 of them. Right? Hold on a second. Yeah. We just have to permute the rest of 13 of them. So which means out of 13, we permute, out of 18, we have to permute 13. Right? So this is just another way of thinking about it. Then divide by, so this is part of the whole thing. So we can divide it by, so basically it's a permute, one way is a permute 18, right? So permutation of 18. So permutation of 18 people, right? Permutation of 18 people. So this is a sample space. So we permute, so we choose, so how many possibilities to choose, to permute, to arrange these 18 students to present. Now the numerator is saying, fixed 5 people already been chosen. So we only have to permute the rest of 13 of them. So if we do this calculation, we still get the same answer. All right, so this is just another way to think about it. But the easy way thinking of it is just this one. Just, how many probabilities to choose the 5 people, first 5 people. Okay, that's all for exam 2. All right.